Today we're going to take a look at some sample problems from section 11.4. In 11.4, if you'll remember, we're dealing with binomial probability. And I'm working in the 12th edition of our textbook, and I'll be starting on page 610 if you're following along in the book. And I want to begin with number 2. It says, if 3 fair coins are tossed, find the probability of each number of heads. So let's think about our sample space. We can have 3 heads, 2 heads and a tails. We can have heads, tails, heads. Heads, tails, tails. Tails and then 2 heads. Tails, heads, tails. Or all tails. I think I have 8 here. 1, 2, 3, 4, 5, 6, 7. No, I'm missing 1. We can have 2 tails and then a heads. Okay. So let's take a look at our probability distribution. X represents the number of heads, and P of X represents the probability of that number. So we can see it's everything from 0 to 3, very much like our case with the 3 children. Probability of 0 heads, we have 3 tails would be 0 heads, so that's 1 out of the 8. Probability of 1 heads, okay, let's see if we can highlight the cases where we have 1, that's 3 out of 8. Let me go back to the yellow. Probability of 2 heads, that's again 3 out of 8. And probability of all heads is 1 out of 8. So we can see that our probability distribution adds to 8 eighths, which is equal to 1. So now we can answer number 2. Find the probability of each number of heads. The number of heads would being 1, that probability is 3 eighths. Okay, in number 4, they want the probability of 3 heads from the same distribution, and that would be probability of 3 is 1/8. Okay, and number 6, the probability of at least 1. So at least 1 would be 1, 2, or 3. We want to add those together. So it's going to be 7 eighths when we add those together. And number 8, we'll do one more on these. Fewer than 3 heads, so we want to add these 3 together. 1/8 plus 3/8 plus 3/8. Fewer than 3. That doesn't include 3. So that's 7 eighths as well. Okay, binomial probability applied to tossing coins. So we're still working with coins on this next page. And it says use the pattern noted in exercises 10 and 11 to find probabilities of each number of heads when 7 fair coins are tossed. So basically what we're going to do is we're going to use our probability, binomial probability formula. So let's take a look at that since we didn't do 10 and 11. And the shortened way to write it is to use combinations of n objects taken x at a time times the probability of success raised to the x power times the probability of failure raised to the n minus x. So let's take a look at number 12. We'll do several of these. And we're tossing 7 fair coins. So n is 7. And this is the way I recommend that you start these. In number 12, x is 0. So what's the probability of getting a heads? Is considered a success here, so it's going to be 1/2. That means the probability of failure will be 1 minus 1/2, which is also 1/2. So we have all of our values. So that means we want combinations of 7 taken 0 at a time times 1/2 to the 0 times 1/2 to the 7th. So that's going to be the probability of 0 successes. So we need a calculator. Get mine over here. Just knocked over my water. Okay. Alright, so combinations of 7 taken 0 at a time is 1. And 1/2 to the 0 is 1. So we have 2 1s. So now I need to raise, I'm going to just put in 0.5 raised to the 7th power. 0.07812. Okay, so the decimal answer would be 0.0078125. Or if you did 1/2 to the 7th, it's going to be 1 times 1 times 1 over 128. And I will accept either answer, except when my math lab gives you instructions on the format. If it says as a decimal, do it as a decimal. If it says a fraction, do it as a fraction. Okay, so let's do number 16. Do at least one more of these. We have the same setup. This time, though, we're looking for 4 successes. P is still 1/2. Q is still 1/2. So the probability of 4 successes would be combinations of 7 taken 4 at a time times 1/2 to the 4th times 1/2 to the 3rd. So let me do my combinations here. It's going to be 35 times, and that's going to be 1/2 to the 7th, which again is 1 over 128. So we're going to get 35 over 128. Or you could do it as a decimal, which would be 35 divided by 128, 0.273, and I usually just round it to 3 decimal places. Okay. And we can do it for 6. Let me see if I can squeeze one more in here. Let's do it for probability of 6 successes. That would be combinations of the 7 taken 6 at a time times 1/2. I'll do 1/2. Raised to the 6 times 1/2 to the 7 minus 1 is 1. Combinations of 7 taken 6 at a time, I believe, is 1. Okay, is 7 rather. And so we get 1/2 to the 7th. So we're going to get 7 over 128. Combinations of 7 taken 6 at a time would be a 7. Okay. All right. Let's move to a different problem or a different group of problems. Let's move down to the group 25 through 28. For n repeated independent trials with constant probability of success p for all trials, find the probability of exactly x successes in each of the exercises below. So in 26, so again, we're using our formula, and I'm going to write it down again. Simply because then each time you write it down, you're helping to commit that to your memory. In 26, we have n equals 10 and p equals 0.7. So that means that our Q, our probability of failure, will be 1 minus 0.7, which gives us 0.3, and our X, of course, in this case, is 5 as part of the given information. Okay, so we have the probability of 5 successes is going to be combinations of 10 taken 5 at a time. Probability of success is 0.7, and we want to raise that to the 5th. Probability of failure is 0.3. We want to raise that to the 5th. So combinations of 10 taken 5 at a time is 252. Okay, once I get that, I'm going to go ahead and multiply this out on my calculator. 252 times 0.7, make sure you use your exponent key, to the 5th, times 0.3 raised to the 5th. And let's see, looks like 3 decimal places is what they want here, so that's 0.102. To the right of the 2 is a 9, so that would be rounded to a 3. Okay, and let's do 28. Using the same formula, this time n is 30, p is 0.6, and x is 22. That means Q is going to be 1 minus 0.6, which would be 0.4. So the probability of 22 successes would be combinations of the 30 taken 22 at a time, times 0.6 to the 22nd, times 0.4 to the 30 minus 22 would be 8. Okay, that's going to be a big number. So let's see, 30 combinations of 30 taken 22 at a time. Okay, so I calculated this. I'm leaving it in the calculator and just hitting times 0.6 raised to the 22nd times 0.4 raised to the 8th. And I'm getting 0.050. Okay. All right, let's stop with that one, and I'll do a couple more examples where we're actually having to add some of these numbers together.